Hello everyone, this is Revati working as an assistant professor in the Department of Information Technology from SNS College of Technology. Welcome back to my channel. In today's video, we are going to understand an important concept in computer networks, that means TCP control, flow control. Imagine, have you ever tried pouring water from a fire hose into a small glass? What happens? It overflows. Similarly, when a high-speed sender sends data to a slow receiver, it causes data loss and congestion. It means it will exceeds the capacity of the receiver. So, how do we control this? That is exactly what is in the computer network is called flow control. Then we will see the definition of flow control. Flow control is a mechanism that ensures the sender does not send data faster than the receiver can handle. It also maintains a balance between sender speed and the receiver capacity. Without flow control, what will happen is buffer overflows, packets are lost, network efficiency or drops. Then next, there are two approaches we are using in flow control. First one is feedback based approach. Then the second one is rate based method. We will see these methods one by one in detailed manner. Receiver, in first method, receiver sends acknowledge or credits, and also sender waits for permission before sending more data from the sender. Then very reliable and adaptive. Then the second method is nothing but rate based method, that means streaming method. In this method, sender sends at a fixed speed rate to the receiver, assumes receiver can handle it. Now continuous feedback will be sent to the sender. Then next, the TCP uses the feedback based approach, making it more efficient than the other method. Then the next is sliding window concept. Now let's understand the heart of flow control, the window. The window represents the amount of data that can be sent or received at a time. Think of it like a moving frame. It expands when receiver is ready. Yes, then it also strings when buffer is full. This is called a sliding window protocol mechanism in the flow control. Then the next is important rule is do not string. There is a golden rule in TCP, do not string the window. This means once the receiver advertises a window size, it should not suddenly reduce it. Why? Because it can confuse the center and it also cause the inconsistencies. Then the next is prime. Next is connection setup. Already we know that TCP is a connection oriented protocol, and it also ensures that the connection is established between the sender and receiver before the original data transmit. And the first is the handshake process. Before starts, TCP performs a handshake. During this, sender and receiver negotiate the window size, and initial limits are set by the both sender and receiver. This ensures smooth and controlled data transfer from beginning. The next is the silly window syndrome. Now let's discuss a common problem, that means silly window syndrome. This happens when very small chunks of data are sent repeatedly to the receiver. In this case, the silly window syndrome will be caused. The example for this one is receiver frees only 1 or 2 bytes, then sender keeps sending tiny packets repeatedly to the receiver. This waste of bandwidth and reduces the efficiency of the receiver. Then the solution for this silly window syndrome is we are using two algorithm for rectifying this silly window syndrome. That means Nagel's algorithm. It can be used in the sender side. Then the second one is Clark's solution that will be used in the receiver side. Let's see this algorithm one by one. Nagel's algorithm, it is already I told that it is used in the sender side. In this process, the first step is combines small data into larger packets, and the second step will be sends only when enough data is collected. Then the next algorithm is Clark's algorithm that will be used in the receiver side. Receiver waits until sufficient buffer space is available by the receiver, then sends an update to the receiver. Together they prevent unnecessary small transmissions. We will see the real world scenario of this flow control. Let's understand with a simple scenario. A sender sends 400 bytes. Receiver buffer becomes full. It advertises the receiver window size will be 0. Receiver processes only 2 bytes, sends update immediately to the sender. This creates an insufficient communication between the source and destination. Let's we summarize this flow control of TCP. Flow control prevents receiver overload and also uses sliding window mechanism for preventing the flow control. Then TCP relies on feedback based control, and problems like silly window syndrome are solved using smart algorithms like Nagel's and Clark's algorithm. Understanding flow control is essential for design efficient and reliable network by using transmission control protocol. Thank you so much for watching.